5, inscribed angles. You'd done an exploration with this, so a lot of the discussion of why all of this works came in the exploration piece. So if you have questions about that, please feel free to see me and I can talk about the why. But again, when we sat down with Sketchpad and discussed and looked at things, you should have been able to discuss that. So an inscribed angle by definition is an angle whose vertex is on a circle and whose sides contain chords of the circle. So if you need a little diagram of kind of what that looks like. Okay, so there's the inscribed angle right there. We found in our exploration that the measure of an inscribed angle is equal to half of the intercepted arc. And again, you had kind of proven this before in a previous homework assignment involving central angles. If two inscribed angles intercept the same arc, then the angles are congruent. If they're equal to half the intercepted arc, they intercept the same arc, they're half of the same thing. They must be equal. An angle inscribed in a semicircle is a right angle. Well, a semicircle is 180 degrees. If the angle is inscribed, it's half of that, which makes it 90 degrees. If a quadrilateral is inscribed in a circle, then its opposite angles are going to be supplementary. If you look at opposite angles of the quadrilateral that's inscribed, the arcs they intercept actually end up intercepting the whole circle together, those angles. A whole circle is 360, so half of that is 180. And again, we went into discussion more on the exploration day of why this works. The measure of an angle formed by a chord and a tangent is also equal to half the measure of the intercepted arc. So I have some diagrams down here. Angle ABC is inscribed. Okay, so this is the angle, and angle AC is the intercepted arc. So it's half of the measure of arc AC. The measure of angle XYZ is here, and it's equal to half the measure of arc XY. I don't have my proper notation here. But if you kind of think of it as an alligator mouth, what part of the circle is it eating? So the arc that's cut off by the tangent and the chord will basically be cut off by the endpoints of the chord and at the point of tangency. Sorry about that. So here we have some examples. Let's see if I can shrink this up a little bit so you can see all of them. Whoa. I'm going to shrink. I'm sorry, guys. I'm trying to make it smaller. All right, so there's some examples. Might need to zoom in a little bit. And what I'd like you to do is just give these a try. It may help to use color to mark the angles. So for example, arc X here, if I trace back the angle that intercepts it and this arc, so for example, in this first one, this angle is 20. I know the arc has to be double that. So angle X must be 40. And sometimes the color has really helped people to kind of trace the lines and then trace the arc that's intercepted. So what I'd like you to do right now is try these examples to the best of your ability. All of these are circle O. So anytime you see it crossing through the red dot, so it's not doing that there or here, it is going to be a diameter. Okay, so push pause and work through. Okay, over here I did the examples. I talked about X is 40. Angle Y, I drew that out. It intercepts this large arc, which is a total of 110 plus 40, which is 150. Half of that is 75. The purple here, I know that purple angle is an angle of 20 and intercepts this arc. If you draw out from angle X, you'll see that the purple and the red overlap. They intercept the same arc, therefore these angles are equal. Angle Y is inscribed in a semicircle, so it's half of the 180 degrees, so it equals 90. Down here, if I drew out to here for the arc of 140 and came back in, this is an angle of 70. There are actually a lot of different ways to approach this problem. I'm just showing you one way, but there are a lot of ways. The 60-degree angle here intercepts this arc. So the arc is double that. That's 120. Angle X in green is here. Half of 120 is 60. So angle X is 60. If you use the fact that the circle is 360, 140 plus 20 is 260. That leaves 100 for this arc here, which is what Y uses. Y is half of that, so Y is 50. In this example, angle X in red, shown in red, intercepts the 80-degree arc. It's half of that, so it's 40. This is a semicircle. So it's 180 degrees. If that's 80, this has to be 100. These chords are equal. Equal chords have equal arcs. So if this arc is 100, this arc is also 100. Angle Y in blue intercepts that 100-degree arc, so it's half of that, so Y is 50. Okay. Now here are 3 more examples again. I would like you to try these to the best you can, writing down anything you know, and then come back and check your answers. Okay, over here, the 80-degree angle comes out to here, so X is double that, 160 degrees. Equal chords mean equal arcs. So if I've taken up 160 degrees here, I have 200 degrees of the circle to split equally between Y and Z, so both of them are 100. Angle X is 30 degrees because it intercepts a 60-degree arc. It's half of that, that's 30. So if this arc is 60, then there are 300 degrees to split equally among the other arcs. I know these arcs are equal because these chords are equal. So half of 300 is 150. That makes Z 150. Over here, again, there are many, many different ways to approach this one. I did forget to put in angle X. I'm going to use the fact that we know that in a quadrilateral inscribed, that the opposite angles are supplementary. So that makes this angle 98. I also know that these chords are equal, so these arcs are equal down here. And Y and Z are going to be half of these equal arcs. They're going to be equal. So you can take the 82, subtract that from 180, since Y, 82, and Z all make a 180-degree angle. That leaves 98 degrees to split equally between Y and Z. Like I said, this problem, the way you got Y and Z may be very different than what I did. Even the way you got X. As long as you're getting these numbers, my way is just one method of getting the answer. So those are the notes for 9-5 that hopefully you worked through and tried. Please let me know if you have any questions.